Hi, and welcome to this video on annuities. An annuity is a series of payments, usually in equal amounts, made at regular intervals for a fixed period of time. Consider the example we have right here, where Megan planned to buy a house but could afford to pay only $14,000 at the end of every 6 months for a mortgage with an interest rate of 5.8%, compounded semi-annually for 20 years. Megan paid $22,750 as a down payment. There are 3 questions we need to work on. First, what was the maximum amount she could afford to pay for a house? Second, what was her total amount spent for the house through the mortgage period, including the down payment, not taking into account the time value of money? And third, what was the total amount of interest paid through the mortgage period? And we need to round answers to the nearest cent. To work with a problem like this one, we need to identify various variables. So we're going to introduce some notation. The $14,000 that we have here correspond to the amount of the periodic payment of the annuity. That's the amount that Megan can afford to pay at the end of every 6 months. So we have PMT equals $14,000. Now we have that that amount is or can be paid at the end of every 6 months. So the payment interval in this problem, or payment period, is 6 months. The payment interval or payment period is a time between 2 successive payments. Now, here we have that the interest rate is 5.80%. That 5.80% corresponds to the nominal interest rate. That's usually denoted by J. So we have J equals 5.80%. And that interest is compounded semi-annually. So we have that the compounding frequency, that's denoted by M, is 2. And then that interest is compounded semi-annually for 20 years. 20 years is the term of the annuity. It's usually denoted by T. It's a time from the beginning of the first payment interval to the end of the last payment interval. And in this example, we have 20 years. We can also say that the number of payments per year is equal to 2 because payments are made every 6 months. And there are 12 months in 1 year. So there we have 2. And then the total number of payments during the term of the annuity will be the product of the number of payments per year by the time period in years. So we do 2 times 20, and that's 40. So that would be 20 payments during the term of the annuity. Another thing we can say is that the periodic interest rate can be found by doing J divided by M. The periodic interest rate, remember, is the interest rate per compounding period. So we're taking 5.80% and dividing it by 2. And when we do that, we find the number 2.9%. And 2.9% corresponds to 0.029 in decimal form. Okay. We have introduced notation to give labels to everything we have been told from the statement of the problem. So we have that the amount of the periodic payment of the annuity is $14,000. The payment interval is 6 months because that's what those $14,000 are the amount that Megan can afford at the end of every 6 months. We have that the nominal interest rate is 5.8%. Because the interest rate is compounded semi-annually, then we can say that the compounding frequency is 2. We have 2 compounding periods per year. Then 20 years is the term of the annuity. The number of payments that Megan can make per year is 2, because she's making payments at the end of every 6 months, and there are 12 months in 1 year. Then N can be computed by multiplying the number of payments per year by the time period in years. And I, the periodic interest rate, comes from dividing J by M, by dividing the nominal interest rate by the compounding frequency. Okay. With all variables in mind, we can move on to talk about the type of annuity we're working with. Because payments are made at the end of each payment period, we have that this annuity is ordinary. So we have an ordinary annuity. And we can say that the compounding period and the payment period are the same, because Megan is paying or is willing to pay that amount of money at the end of every 6 months. And the interest is compounded semi-annually. In other words, this M right here is the same as this number of payments per year. That means that we're working with an ordinary simple annuity. So the type of annuity we're working with is ordinary and simple. And now that we have the classification clear, we can start working on parts A, B, and C of this problem. Okay, so let's start with part A. We want to know the maximum amount Megan could afford to pay for a house. That maximum amount comes from finding the present value of the annuity. We want to know how much she could afford to pay for the house, given all the information that is given in the statement. To calculate the present value of all the payments at the beginning of the 20-year period, we calculate the present value of each payment and then add all the present values using a compound interest formula. And then we need to add the $22,750, that is a down payment, to that amount. Now there is a simplified formula used in present value calculations. In the case we have ordinary simple annuities, and that formula tells us that the present value of an annuity equals the periodic payment. So we have PMT multiplied by 1 minus 1 plus I to the negative n divided by I, where n is the number of payments during the term and PMT is a periodic payment and I is the periodic interest rate. Then what we have is that the present value of those $14,000 Megan is willing to pay at the end of every 6 months for a mortgage with interest rate of blah, 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 and all that for 20 years is given by 14,000 multiplied by 1 minus 1 plus 0.029 to the negative, and n is equal to 40, divided by 0.029. And we can use a calculator to compute this amount. When we use a calculator, we get a value that can be approximated by $328,902.40. If you're using a calculator and you need to get to this number right here, then make sure to go with something like 14,000 times bracket, then bracket again, 1 minus bracket, 1 plus 0.029 raised to the power of bracket minus 40, close bracket, then close bracket, and then divided by 0.029. That's how you can find the value approximately equal to $328,902.40. Now, the maximum amount that Megan could afford to pay for the house will be that present value plus a down payment. So we take those $328,902.40 and add $22,750, and that gives us the value $351,652.40. So that's the maximum amount Megan can afford to pay for a house given the conditions that are given in the statement of the problem. Okay. Now let's move on to part B. So I'm going to erase here. Let's erase what we did so we can move on and work on part B. Okay. So B. Now the total amount Megan spent for the house through the mortgage period, including the down payment, corresponds to the addition of all the payments. We have 14,000, 40 times, and the down payment. So we have 22,750. If we forget about the time value of money, then the total amount Megan spent for the house through the mortgage period, including the down payment, is 14,000 times 40. 40 is N, the total number of payments during the term of the annuity, and then plus a down payment. And when we compute the addition, we find the number $582,750. Okay, so that's all for part B. As for part C, to find the total amount of interest paid to the mortgage period, we calculate amount equals the amount that she invested, so the amount from part B, so what was invested, and we subtract the present value, or in this case, the right. So we have the present value of the money that she's willing to pay for the house. So we have the investment, and that's $582,750. The total amount spent for the house through the mortgage period. And then we subtract, and actually here, remember we had like present value plus the amount 22,750. Remember we had that based on the variables we had. It's present value of those payments of $14,000 every 6 months for 20 years, and then plus a down payment. So we take this and subtract what we got from part A of this problem, and that was $351,652.40. So this is approximate at this point. We do this, and then with that, what we have is the subtraction of those numbers, and that should be equal to $231,097.6. So the total amount of interest paid through the mortgage period was about $231,097.6. Okay, so to summarize what we did, we can say that we looked at the statement of the problem. We started introducing variables like PMT for the amount of the periodic payment, the payment interval, the nominal interest rate, the compounding frequency, the term of the annuity, the number of payments per year. Then we found the total number of payments during the term of the annuity by multiplying the number of payments per year by the time period in years. Then we found the corresponding periodic interest rate. And then we classified the annuity as an ordinary simple annuity. And we used that classification to pick the formula we wanted to use to compute the present value of the annuity. That was the most complicated part A, and then for part B and from parts B and C, we just went ahead with much simpler formulas. For part B, the total amount spent for the house through the mortgage period, including the down payment, was those $14,000 that Megan was willing to deposit every 6 months for 20 years, multiplied by 40. The total number of payments, and then we added the down payment, while the total amount of interest paid through the mortgage period was the subtraction of two things. We had investment minus the result of part A, the maximum amount she could afford to pay for a house. Okay, so that's all for this example. If you have questions, please write comments or contact me, and I will try to assist you. Thank you for watching, and that's all. Bye-bye.